Geothermal energy is one of the lesser-known forms of sustainable energy, but it is utilized in a lot of different places, both privately and commercially. To demonstrate this technology, you will need a fish tank, a few feet of copper tubing, some larger diameter plastic tubing cut into two roughly 2-foot long pieces, a large pot, rocks, an aquarium water pump, a hot plate, 2 beakers, and 2 thermometers. This experiment is a little more involved, but it is very effective at explaining a unique concept. The first order of business is to heat up the rocks. Turn on the hot plate and add the pot with the rocks inside it. Then fill the pot to the level of the rocks with water and place the lid. This will need to heat for a few minutes. In the meantime, prepare the fish tank. To set this up, first the copper tubing should be coiled into a circle to increase the amount of time the water spends in contact with the hot rocks. Then the aquarium pump and the plastic tubing should be attached and tested to see if water can be pumped from one beaker through the tubing and to the other beaker. Once the stones have been heated to around 120 degrees Fahrenheit, they can be removed from the heat. The stones should be carefully removed and put over top of the metal tubing. To finish setting up the tank, you should place a full beaker of water at the end with the aquarium pump and an empty beaker at the other end. Make sure the aquarium pump is attached at the end with a full beaker of water, and take a temperature measurement of the water before it is pumped through the tubing. Next, you can plug in the aquarium pump until the tube is full of water. Then you can unplug it and let it sit for 2 minutes or so until it has a chance for the rocks to heat up the water. We also measure the temperature of our rocks after heating to have as an interesting reference point. Once you've taken the temperature, you can plug pump back in and push some water through the tube to fill up the other beaker. Take the temperature of the water in the second beaker so we can determine how much the temperature increased based on how much time was spent in the rocks. In order to get a better understanding of what our data actually means, we can graph it in Excel. You should enter the initial temperature, the final temperature, and the time the water spent in the rock, and then use those to calculate the change in temperature over time. You do this by subtracting the initial temperature from the final temperature and dividing by the time that it's spent in the tubing. While this example is a little dramatic in that the rocks are heated significantly above standard temperatures, this technology works even when the heat of the Earth is closer to room temperature. There are even commercial power production plants that produce energy using the heat of geothermal hotspots located near tectonic plate boundaries. This experiment could also be modified by measuring the effect of different flow rates on the heating of the water. This could be accomplished by adjusting the flow rate on the pump itself if you have that option, or by clamping the plastic tubing to reduce the amount of water that can flow through. You can measure the flow rate by tracking how much water is added to the second flask by how much time has passed. Try this at a few different flow rates to see how this affects the increase in temperature of the water.